Welcome back. In this session, we will solve some examples of circular convolution. Let's start. So, in the previous session, we had a little bit introduction about circular convolution and a circular convolution between two sequences x1 of n point circular convolution between two sequences is defined like this: k equals 0 to n minus 1, x1 of n minus k modulo n x2 of x2 of t. So this is how we define the circular convolution. Right. Now today we will solve an example, and let's take the example like this. Let's suppose x1 of n is, let me take an example like 1, 2, 1, 0, and x2 of n is, let's suppose 0, 1, 2. Okay, so these are our three sequences, and we will try to evaluate the circular convolution between x1 and x2 of n. Alright, let's start. Today we'll use, in this session we'll use the formula, in the next session we'll do it graphically. That will be, that's very simple approach. Now in this session we'll use the analytical approach. Right, so to evaluate y of 0, what we'll do, we'll put n equal to 0, so this will be just y of n minus, and n is equal to 4 here, so we have to evaluate 4 points. Yes, so this minus n is 4, so it will be n minus 1 is 3, x1 of 0 minus k, that is minus k modulo 4, x2 of k, right? So substituting the values of x1 of k, we will get 0, sorry, not 0, we'll get x1 of 0 modulo 4, x2 of 0 plus x1 of, sorry, yes, x1 of minus 1 modulo 4, x2 of 1 plus x1 of minus 2 modulo 4 when k is 2, x2 of 2 plus x1 of minus 3 modulo 4, x2 of 3. Alright, as k varies from 0 to 3. Now, in the previous session, if you remember, I said 0 modulo 4 is 0, so you don't need to do anything about this. x1 modulo 4, so this will be 4 minus 1. So to evaluate this modulo operation, simply add 4 to this. Similarly, x1 of 4 minus 2, it will be x of 4 minus 2, so x2 of 2 plus x1 of 4 minus 3. This is where evaluating the modulo operation, and minus 3 modulo 4. So add simply 4. So this one is x of 0, x of 1. Now let me evaluate it further. 3, x2 of 1, x1 of 2, x2 of 2, x1 of 1, x2 of 3. So substituting the terms, these are given to us. x1 of 0 is 1, x2 of 0 is 0, x1 of 3 is this 0, plus x2 of this is 1, so 0, sorry, I think I did wrong, so 0 multiplied by x2 of 1 is 1, x1 of 2 is 2, multiplied by, I think I did it wrong, pay attention, so x1 of 3 is 0, yes, right, x1 of 3 is 0, x2 of 1 is 1. Then x1 of 2 is this, so it will be 2 multiplied by this 2, x2 of 2 is 2, plus x1 of 1 is 2 multiplied by x2 of 3. this is 0 plus 0 plus 4 plus 6. So this is 0 plus 0 plus 4 plus 6 plus 10. Similarly, y of 1 is equal to 0 to 3. 0 to 3 rather. This will become 0 to 3. Next 1 of 1 minus k 4 next to a 2. So let's evaluate the summation. So this is y of 1 and n is equal to 1. So this will be x1 of put k equal to 0. This will be 1 modulo 4 x2 of 0 plus x1 of 1 modulo 1. 1 minus 1 is 0, so 0 modulo 4 x2 of 1 x1 of 1 minus 2, that's minus 1 modulo 4 x2 of 2 plus x1 of 1 minus 3, that is minus 2 modulo 4 x2 of 3. Right? So let's evaluate it. 1 modulo 4 is 1. Remember that 1 modulo 4 is 1. x1 modulo 0 modulo 4 is 0. And how do we evaluate this? We add 4 to it, so it will be 4 minus 1, that's 3. x2 of 2. How do we evaluate this modulo? We add 4 to it. This will be x1 of 1 of 4 minus 2 is 2, so it will be x2. Okay, now substituting the values. What are the values? What are the values? X. Let me copy the values here. So the values are x1 of 1 is 2, x2 of 0 is 0, x1 of 0 is 1, x2 of 1 is 1, x1 of 3, x1 of 3 is 0, x2 of 2, x2 of 2 is 2, x1 of 2 is 2, x2 of 3 is 3. So this is 0 plus 1 plus 0 plus 6 is 7. So our y of 1 is 7. So we have computed y of 1. Next, we'll compute when n is equal to 2. Put n equal to 2. So the summation becomes from k x1 of 2 minus k modulo 4 x2 of k. So substituting the values of k in this summation, so we'll get x1 of 2 minus 0 is 2 modulo 4. So 2 modulo 4 x2 of 0 x1 of if we put k equal to 1, this will be 1 modulo 4 x2 of 1. Am I done it right? 2 minus 1 is 1, yes. So x plus x1 of 2 minus 2, when k is equal to 2, this will be 0 modulo 4 x2 of 2 plus x1 of x1 modulo 3, this will be minus 1 modulo 4, and this will be x2 of 3. So let me simplify. 2 modulo 4 is 2. 1 modulo 4 is 1. I hope I'm doing it right. x1 0 modulo 4 is 0. What we do here, we add 4 to it. When the argument is negative, we add 4 to it, so it will be 4 minus 1, that is x1 of 3. Right? So let me copy the values of x of n are 1, 2, 2, 0, and x2 n are 0, 1, 2, and 3. So substituting these values here, we get y of 2. So y of 2 will be simply x1 of 2 is 2, x2 of 0 is 0, x1 of 1 is 2, x2 of 1 is 1. So 2, 1, x1 of 0 is 1, x2 of 2 is 2. We check the value whether I have any right or wrong. x1 of 3 is 0, x2 of 3 is 3. So it will be 0 plus 2 plus 2 plus 0 is 4. Right? So this is the answer. Now when n is equal to 3, so we'll get y of 3. Y of 3 will be summation k from 0 to 3, x1 of 3 modulo k 4, 3 minus k modulo 4, then x2 of k. So substituting the values of k, will get x1 of 3 modulo 4, x2 of 0, x1 of, when k is equal to 1, this will be 2 modulo 4, x2 of 1, x1 of 1 modulo 4, x2 of 2, plus x1 of 3 minus 3 will be 0 modulo 4, x2 of 3. Now using the values that are given here, so sorry, first let me evaluate this. So this will be 3 modulo 4 will be 3, 0 plus x1, 2 modulo 4 will be 2, x2 of 1 plus x1 modulo 4 is 1, 0 modulo 4 is 0, x2 of 3. So substituting the values, copy the values from there. x1 of 3 is 0, x2 of 0, x1 of 2 is 2, x2 of 1 is 1, x1 of 1, x1 of 1 is 2, x2 of 2 is 2, x1 of 0 is 1, x1 of 0, right, and this is 3. So this will be 0 plus 2 plus 4 plus 3. How much is that? 7, 9. Yeah, this is 9. So our y sequence, minus y of 10 is simply 10, 7, value 4, 9. So this is our sequence. So our circular convolution between x1 of n and x2 of n is this sequence. So this is how we evaluated the sequence. Right? So this is how we obtain the circular convolution. Now here is an assignment for you guys. Please try to solve it. Now x1 of n is 1, 2, 2, and 1. x2 of n is 0, 3, 2, 1. So this is our one sequence. This is our one assignment. Second assignment is x1 of n is 0, 2, 0, 3, 0, 1. So this is our one sequence. x2 of n is 1, 2, 3, 4. And find the 6-point DFT. Here you have to find 6-point, circular convolution. So you have to evaluate x1 of n, 6, x2 of n. What is this? And you are here, you have to perform 2. x1 of 4 point first. What is this? And then you have to find 6-point convolution. So you have to solve this twice. This is right. Let me end the session here. In the next session, we will learn the very simple procedure of how to evaluate the circular convolution.